Standard 5.4, solve trig equations that require application of double angle formulas. So let's take a look at our first example. Cosine 2x minus cosine x equals 0. Now, even though we only have one trig function in this equation, which is cosine, there's a slight problem in the fact that we have two different arguments. We have 2x as one of our arguments and x as the other argument. And when we have two different arguments in our equation, we can't solve it until we make a substitution of some sort so that we only have a single argument. So cosine 2x should tell us that we need to look at our double angle formulas. Now there are three different double angle equations for cosine. And we want to make a smart choice. Now if we go back to our equation, notice that it's all cosines. And so let's pick the double angle formula that is all cosines. So we're going to pick the middle one here, 2 cosine squared a, or x, minus 1. So let's make that substitution. Cosine 2x becomes 2 cosine squared x minus 1. Then we have a minus cosine x equals 0. So we've done a substitution here. We replaced cosine 2x with 2 cosine squared x minus 1. We're allowed to do that because of the double angle formula. Now we have only one trig function and we have only one argument, which is x. Notice this is a quadratic because we have the squared, the exponent squared there. So we're going to have to factor. And what we've been doing in class is taking the trig out while we factor and then putting the trig back in at the end. So to take the trig out, we're going to let y replace cosine x. So we have a new equation here, 2y squared minus 1 minus y equals 0. Rearrange terms so that they're in standard form. And then we want to factor. So we're going to play around with our factors here. We know that this term times this term has to give us 2y squared. So the only way that we can split up 2y squared is 2y and y. We know that this term times this term has to give us a product of negative 1, and that means we're going to have a plus 1 and a minus 1. We don't know which side is the plus and which side is the minus, but now what we're going to do is we're going to check to see if our factoring is correct. Multiplying the two greens together, we get 2y squared. Distributing 2y to the negative 1, we get minus 2y. Distribute the 1 to the y, we get plus 1y, and 1 to the negative 1, we get minus 1. And when we simplify this, we get 2y squared minus y minus 1. And notice that these two terms combine to make our yellow term, which is what we want. So our factors are now 2y plus 1 and y minus 1. And these are equal to 0. And what we're going to do is set each factor equal to 0 to solve for y. So set 2y plus 1 equal to 0, subtract 1, divide by 2, and we get y equals negative 1/2. Set y minus 1 equal to 0, add 1, we get y equals 1. Now let's put the trig back in our equation since we've solved for y. We're going to replace y with cosine x. So we have cosine x equals negative 1/2 and cosine x equals 1. Solving on the left side, cosine is half for a reference angle of 60 degrees. Let's just verify we're in degrees here. Yep. And cosine is negative in quadrants 2 and 3. So our 60s in quadrant 2 and 3 are 120 degrees and 240 degrees. Okay. Here where cosine x equals 1, that's quadrantal. Cosine is the x-coordinate, and that's equal to 1 over here at 0 degrees. And so our three solutions are 120 degrees, 240 degrees, and 0 degrees. The big idea again in this problem is making a substitution with one of your double angle formulas so that you have consistency in both your trig function and in your argument. And then you can solve like we've been solving quadratic trig equations in previous units. All right, our second example, we have cosine squared minus sine squared equals negative 1/2. Now here, if you observe, we have two different trig functions, cosine and sine. So let's see if we can find a substitution here. Notice that cosine squared minus sine squared, I'll highlight that in green here. Cosine squared minus sine squared is equal to cosine of 2a, or 2x. This is a double angle for cosine. So we're going to make a substitution, and we're going to replace cosine squared minus sine squared with cosine of 2x. So I'll color code in green here. We're replacing one green expression for another green expression. They're equivalent based on our formula sheet. Equals -1/2. So now we have only one trig function. We only have one argument. Now notice that we're dealing with 2x as our argument. That's telling us that we're going around our circle 2 times, 2 rotations. And so we're going from 0 to 4 pi instead of 0 to 2 pi. So we're going to go around our circle 2 times. Now cosine is equal to 1/2 for our 60s, or our pi over 3s. So here's our 60s, or our pi over 3s. Alpha is 60, or pi over 3. And let's do this in degrees first, and then you can kind of see it in radians. I think it'll be easier to understand. And so in degrees, our solutions are 120 and 240. Now notice our argument is 2x, so these are solutions for 2x, 120 and 240. Now the 2 indicates that we're going around our circle twice. So we're going to add a second rotation. And in our second rotation, we're essentially adding 360. So if we start at 120 degrees and add 360, we are now at 480 degrees, which is another solution. And if we take 240 and add 360, we're at 600 degrees. So we have 4 solutions because we have 2 rotations. These 2 last measurements are what we get on our second rotation. Now if we were to find these angles in radians, notice that 60 degrees is equal to pi over 3. 120 is 2 60s, so 120 would be 2 pi over 3s. 240 are 4 60s, and so that would be 4 pi over 3s. 480 are 8 60s, and so that would be 8 pi over 3s. And 600 degrees are 10 60s, so that would be 10 pi over 3. Now we're solving for x, and we've only solved for 2x so far. And so what our next step would be is to divide by 2 for x. Now if we're in degrees, you could divide by 2 and get 60, 120, etc. Right? But if we're in radians, it's easier to multiply by 1/2 than it is to divide by 2. Because if we multiply each of these by 1/2, essentially we're just multiplying each denominator by 2. So 1/2 times 2x, that just becomes plain old x. Multiplying each of these by 1/2 makes this 2 pi over 6, 4 pi over 6, 8 pi over 6, and 10 pi over 6. And if we wanted to be really good, what we could do is reduce all of these. So pi over 3, and 2 pi over 3, and 4 pi over 3, and 5 pi over 3. Essentially, we're taking all of our angle measurements there and finding half of them. So these are our 4 solutions in radians. These would be our solutions in degrees. Again, notice that we made a substitution using a double angle formula so that we had an equation that was more easy to solve. This is standard 5.4, solving trig equations that require the application of double angle formulas.